Okay, let's talk about how you can find the average and the uncertainty in the average for a number of measurements. So for instance, let's start out with an example. Let's say that you measure the velocity of an object and you do your experiment 6 times. You have 6 trials where you measure the velocity. And let's say that the values that you get are 0.32 meters per second, 0.35 meters per second, 0.28 meters per second, 0.37 meters per second, 0.29 meters per second, and 0.34 meters per second. Pretty consistent. Good data. So in order to find the average, well, finding the average is very easy. You've done that before. If you find the average, you add it up, divide by 6, and you get 0.325 meters per second. Okay, that's fine and good, but that doesn't take into account your uncertainty or your significant digits. So the way that we calculate the uncertainty is you take the maximum value, you subtract the minimum value, and you divide by 2. That will give you your uncertainty in the average. If you do that for this data, you get 0.045 meters per second. That is the uncertainty. However, you have to remember 2 cardinal rules for uncertainty. And the first one is your uncertainty can only have 1 significant digit. Your uncertainty can only have 1 significant digit. So this uncertainty, 0.045 meters per second, that can't be. You need to take that down to 1 significant digit. So that becomes 0.05 meters per second. That is now your uncertainty. Okay, not so bad, right? We have an uncertainty and we have an average. But the second big rule is the last decimal place of a measurement must be the same as the decimal place of the uncertainty. So what that means is, let's see, what is the decimal place of our uncertainty? The decimal place of our uncertainty is the hundredths place. We have 0.05. 5 is in the hundredths place. So the last decimal place of our measurement must be the same as the decimal place of the uncertainty. The last decimal place of the measurement has to be the hundredths place, in other words. So our measurement, the average, becomes 0.33 meters per second. So the final answer is 0.33 meters per second plus or minus 0.05 meters per second. And that is our average and the uncertainty in the average. Okay, let's look at one more example. So let's say our data set is another set of velocity measurements. Now it's 0.41 meters per second, 0.22 meters per second, 0.31 meters per second, 0.43 meters per second, 0.29 meters per second, and 0.31 meters per second. We calculate the average of that, and you get 0.3283333 repeating meters per second. And you calculate the uncertainty. You take the maximum, you subtract the minimum, and you divide by 2. And that gives you 0.105 for the uncertainty. However, remember, the first rule is uncertainty can only have 1 significant digit. So your uncertainty becomes 0.1 meters per second. And the second rule is the last decimal place of the measurement must be the same as the decimal place of the uncertainty. The decimal place of our uncertainty is the tenths place. So the last decimal place of the measurement must be the tenths place also. So our average is 0.3 meters per second plus or minus 0.1 meters per second. Now I have not covered every single difficulty that might come up with uncertainty. There are some strange situations that we'll encounter in the future, but this is a good start, and this should get you through the lab for now.